Reduction formula for integration cos power nx dx. Integration cos power n x dx can be written as integration cos power n minus 1 x times cos x dx. Now we can integrate it by part. So we keep this term as differentiable and this as integrable. So it will become cos power n minus 1x, and integration of cos x will give sin x minus differentiation of this term will give n minus 1 times cos x power n minus 2 into integration of cos x will give sin x. Also differentiation of this, because we have to write n minus 1 before, then this cos x will get reduced by power 1, then differentiation of it. So that will give minus sin x, then dx. So this will become cos power n minus 1x sin x, and here there is minus sign, this is also minus sign, this will become plus, and we can write n minus 1 outside. Then integration cos power n minus 2x times sin square x, and sin square x can be written as 1 minus cos square x dx, which is equal to cos power n minus 1x times sin x plus n minus 1 integration cos power n minus 2x dx minus n minus 1 integration cos power n minus 2 and 2 will make it cos power nx dx. And we have started from cos power nx dx integration, so we can take it this side in LHS. So 1 plus n minus 1 times integration cos power nx dx is equal to these two terms. So cos power n minus 1x sin x plus n minus 1 integration cos power n minus 2x dx. So we can write further, this will become n. So integration cos power nx dx equal to, we can divide by n each term, cos power n minus 1 x times sin x whole divided by n plus n minus 1 divided by n times integration cos power n minus 2 x dx. So this is reduction formula. Now let's consider next thing, 0 to pi by 2 cos power nx dx, where n is a positive and positive even and odd integers. Both cases we will discuss separately, positive even and positive odd integers. Now let's write it as in is equal to 0 to pi by 2 times cos power nx dx, which can be written as 0 to pi by 2 cos power n minus 1x times cos x dx. Now further, we use integration by part and we integrate it. So this we keep as integrable function, this differentiable function. So we write cos n minus 1x times integration of cos x will give sin x, then limits 0 to pi by 2 minus 0 to pi by 2, and then we differentiate it. So n minus 1 cos power n minus 2 x times minus sine x times integration of this will give sine x dx. So here, if we put the limits, when we put 0, this term will become 0. When we put pi by 2, this term will become 0. So ultimately, this will be 0. And here, this is minus sign, this is minus sign. So we can write plus n minus 1 integration 0 to pi by 2 cos n minus 2x times sine square x can be written as 1 minus cos square x dx. So we further simplify it. This becomes n minus 1 times 0 to pi by 2 cos power n minus 2x dx minus n minus 1 integration 0 to pi by 2 and cos power n minus 2 and cos square will make it cos power n x dx, which is question itself. So we can write it as in. So in equal to n minus 1 times. This can be written as n minus 2 because power is decreased by 2. Initial power was n, now it is n minus 2. And this can be written as n minus 1 and this is in, which can be further simplified. So we can write it in plus n minus 1 times in will give n minus 1 times in minus 2. So here only n will be left and other things will get cancelled. So we can say in will be equal to n minus 1 upon n times in minus 2. Now, if we replace n by n minus 2, replacing n by n minus 2. So here this will become n minus 2. Here this will become n minus 3. This will become n minus 2. This will become n minus 4. So we can say in minus 2 equal to n minus 3 divided by n minus 2 in minus 4. Similarly, we can take other terms, but here we have got value of in minus 2 that we can put here. So we will get in equal to n minus 1 upon n into n minus 3 upon n minus 2 times in minus 4. So this can be generalized further. So we can take the value of n as even and odd. So case 1 we consider when n is even positive number. In that case, in can be written as in equal to n minus 1 upon n into n minus 3 upon n minus 2 into n minus 5 upon n minus 4 and so on. And this will become 1 by 2, the last term, times I0. And we can evaluate I0 because we have in equal to cos power n x dx 0 to pi by 2. So if we put I0 here, so we will get cos power 0 will give 1. So integration will be x and then limits will be 0 to pi by 2. So we will get pi by 2. So we can put this value here. So this thing n minus 1 upon n minus 3 upon n minus 2 into n minus 5 1 n minus 5 n minus 4 dot 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 1 by 2 times here we will write pi by 2. And now we consider the case when n is odd integer. So case 2, when n is odd positive integer. In that case, in will be equal to n minus 1 upon n into n minus 3 upon n minus 2 into n minus 5 divided by n minus 4 and so on. And last term will be, since n is odd, so this will be 2 by 3 into, last term will be I1. Now we can integrate to get I1. So we have In as 0 to pi by 2 cos power nx dx. So if we put n equal to 1, so I1 equal to 0 to pi by 2 cos x dx. The cos x will give sin x and limits 0 to pi by 2. So this will give 1. So here we can put 1. So we will get In equal to n minus 1 upon n into n minus 3 upon n minus 2 into n minus 5 upon n minus 4 dot 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 into 2 by 3 into 1. So we have got the relation for the two cases, and this is called Walli's formula for cos power nx. So we can write in short Walli's formula. So we can say 0 to pi by 2 cos power nx dx. We have seen all the cases when n is even positive integer, we have got this, and when n is odd positive integer, then we have got this. So these two results can be written together. So that we are going to write. So we can say n minus 1 upon n into n minus 3 upon n minus 2 into dot 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 dot, and last result was, it was here till 1 by 2 last term. So 1 by 2 times, sorry, it was, I do this 5 by 2, 5 by 2. So we write last term like 5 by 2, and here we write for n being even integers. And so we are here. So last was, it was 1 by 2 times 5 by 2 for n as even integer. And the same thing can be written for odd integer. So we can say n minus 1 upon n into n minus 3 upon n minus 2 into n minus 5 upon n minus 4 and so on. And last term, as we have evaluated, it is 2 by 3. When n is odd positive integer. Here this is also positive integer. Thank you for watching.